Hello guys, welcome back to my channel, Mason African Motives, working on A-level mathematics, that is for pure mathematics, covering for A-level mathematics, Zimsec, and also covering for all part of A-level math that we have, that is for other departments, despite the one that we have for Zimsec. But in this platform, just quickly, we're working on what we have here. We've got the logarithmic and the part of exponential equations that I want us to just focus on under Mason African Motives. So if you're new guys, you can consider being part of the family Mason African Motives by subscribing to this channel so that you won't miss any of the classes that we shall be having. And also don't forget to share our platforms to your friends and colleagues so that they also can benefit from this platform. So anyways guys, quickly rushing through this particular topic that I want us to consider. Remember, if you are working with exponents, logarithms, you've got conditions that you have, which is from your basic O-level mathematics, which is this part that I want to just explain from where it actually started from, where I'll be given an exponential equation like this, where I'm supposed to apply the laws of exponents or the laws of logarithms, in this case, to solve this equation. In this particular section, we all understand that I can simply make these bases to be the same, the 2 and 8, whereby I can write this as 2 to the exponent of 3. And the moment that these two are the same, the bases, it means the exponents are the same. Definitely, x is going to be what? It's going to be 3. But now, on our level that we are now, you will be given a condition like this one, where I want to explain from it, then I will be able to add more as we are moving on. We are given a condition like this, where we are asked to solve the equation, that is the equation that we have, giving your answer to 3 significant figures. This is actually from one of the question papers that I just took from. We are given such an equation that we are asked to solve 3 to the exponent of 2x, which is equivalent to 4 to the exponent of 2 minus x. All right. On this condition, or on this particular section, it's not possible for me to make these bases to be the same. So at this stage, we have the introduction now of the logarithms, whereby I can introduce the log, referred to as the ln, or the log. This one is an Aperian logarithm, as you know, or you can introduce this log. So one and the same thing. So this is what I'm going to do. I'm going to introduce log both sides of the equation, which is going to be ln 3 to the exponent of 2x, which is equivalent to ln 4 to the exponent of 2 minus x. But remember that the moment I have introduced the log, it means I am now under logarithms. Everything has to follow the protocol or the laws of logarithms. That is where I know that if I am given ln a to the exponent of b like this, I can write this as b ln a. Simply drop the exponent to multiply the logarithm. So that is the case. So I'm just going to drop this exponent here, which is going to be 2x ln 3, that is equal to, drop this exponent here, which is going to be 2 minus x, that is times ln 4. So that means I can actually expand by ln 4 into the bracket. That's 2x ln 3 is equivalent to 2 by ln 4. That's 2 ln 4 minus x times ln 4, which is minus x ln 4. Now at this stage, I have a simplified part. I'm no longer having the brackets, but as I can see, I'm having the terms which are having x. So I'm going to collect terms of x to one side of the equation. That is a transpose. This is going to be 2x ln 3, the minus x to the right hand side, that will be a plus x ln 4, which is equivalent. Already here we have got 2 ln 4 that is going to be left on the right hand side there. Then what can I do? I want to solve for x, but I can see that there is x here, there is x here now. So I can actually factor out the x because it's common. So you can factorize at this stage the x out of the bracket, that is the x here. You're going to be left with 2 ln 3. If you factor out the x here, that means you're going to be left with what? With ln 4, which is going to be equivalent to 2 ln 4. And at that stage, you can apply your mathematical skills. Just divide by the bracket both sides. That means you are actually removing the part that is affecting x on the left side. So that means by doing this, I'm going to be left with the value for x now, simply cancelling these two. Therefore, I'm remaining with my x, which is going to be, use your calculator properly. So if you have to apply your calculator properly, you're going to obtain something like 0,7, that's 0,7737, and so on. So you can just round it to three significant figures. That's going to be 0,774, like the instruction gave us, to 3 significant figures. So as you can see, guys, this is how actually you're supposed to apply the concept that you have when solving these typical equations. So on this one, I don't want us to waste much time. I want you to actually try these questions. I want you to solve the following equation, giving your answers to 3 significant figures where necessary. So just try and apply the concept. As you can see, it's actually clear. Introduction of the lean both sides, and so on and so on. Then you can just solve. So that is the condition or the question that we have. So I want us to try these questions and see if we are able to answer and understand. So the feedback, guys, I need the feedback on these questions so that we'll be able to understand if we are truly moving together. All right, then there is another set of questions that we are given, or another type of questions that we might have, like this one, where I'm given to use logarithms to solve the equation. That is the equation giving your answer correct to 3 significant figures, and that is actually 4 marks for that. All right, taking this equation, I'm having in this case, that's 3 to the exponent of 2x minus 1, which is equivalent to 2 by 3 to the exponent of x. Yes, it's true that I can apply the logarithms. It's fine. I can just introduce logarithm, let log, and so forth. But this is another type of a question that you can actually apply this concept, because here these bases, they're the same. If you were to cross check it, this is 3, this is 3. So there is something that we can do there which is actually common from these two. And what is it that we can do? Can we try to separate these in terms of 3, in terms of the base of 3? When I'm saying to separate, I mean on a condition like this, where we are given 3 to the exponent of 2x minus 1. If we are to cross check, there is something that we are adding here. Let me introduce this way. There is something that we are having that is combined to this part. So you can ask yourself to say, before we had this subtraction, what was actually happening here? It means we are dividing. This was 3 to the exponent of 2x divided by 3 to the exponent of 1. If you have to cross check from your laws of exponents, if the base are the same, you subtract the exponents. So that was actually the case. So this you can actually have it like this. If the base are the same, you know that you subtract. So that is what it was before. It was written like this. So you're going to separate this into this form, which is 3 to the exponent of 2x over, instead of writing this as 3 to the exponent of 1, just write it as what? As 3, just one and the same thing, which is equivalent to 2 into 3 to the exponent of x. Here there's nothing that I can do, it's already x. It's not like I'm having, maybe if it was x plus 1, I was going to separate this as 3 to the exponent of x times 3 to the exponent of 1, but this is just x, so there's nothing that I can do. But as you can see, we have involved a fraction. So make this term a fraction so that I'll be able to cross multiply, because the moment I'm given like this, in order for me to remove the fractions, definitely I've got one part which is to cross multiply to remove this fraction, which is going to be 1 times this part, which is 3 to the exponent of 2x, which is equivalent. Here we can multiply 3 and 2. These two numbers, they can actually multiply each other direct, which is 6 by 3 to the exponent of x, like this. Why am I having this? Why am I writing like this? Okay, this is what is going to happen. Can we just take these terms to one side so that I can explain what is going to happen? Okay, so let's just transpose this. It's going to be minus 6 3 to the exponent of x, which is equal to 0, because we've taken this to the left hand side. Okay, Our main aim was to write our expressions in terms of, or these terms in terms of 3 to the exponent of x, but as single terms. Like this one is a single term, it's a single term, unlike this one where it was a combined part, where we had an expression where we are subtracting there. Now we have got single terms of 3 to the exponent of x, but this is to the exponent of 2x, and this is common somehow. So this is what I'm going to do. I'm going to introduce another letter in place of 3 to the exponent of x, which is the least part that I'm having here. So let's say let y be equal to 3 to the exponent of x, or you just choose any letter of your choice. All right, so that means if I am to introduce in place of 3 to the exponent of x here, if I'm to introduce y, that means here this is 3 to the exponent of 2x, which I know that it can be written like this. 3 to the exponent of 2x is the same as, remember, I want to write it in terms of 3 to the exponent of what? Of x. So this is going to be 3 to the exponent of x, like this, to the exponent of 2. I haven't changed anything from your laws of exponents. You know that these two can actually multiply. X times 2, that is 2x. So that means this here is same as 3 to the exponent of x squared. So if in place of 3 to the exponent of x I'm introducing y, that means this is same as what? As y squared, because this is y here, which is being squared, minus 6 here is 3 to the exponent of x, which is equal to y, which is a 0, like that. So that is what you're going to have, and now you're left with a normal equation that you are used to, that you can even solve even closing your eyes. You know that this one you can actually solve it. It's a normal quadratic equation where you can just factor out the value of y and you'll be left with y minus 6 if you factor out this, and that means our y is going to give us a 0 here, or another value of y is going to be minus 6 to the other side, which is going to give us a positive 6. So that's what you have there. But these are not the answers, because you are not asked to solve for y, you are solving an equation for x. This is x here. So we must obtain an answer in terms of x. So that means I have to come back here where we introduced the letter y in place of 3 to the exponent of x. Since now I have the values of y, I can now take back this statement, because we said let y be equal to 3 to the exponent of x. So if that is the case, that our y is 3 to the exponent of x, that means here I'm going to equate this 0 here in place of y to 3 to the exponent of x. Or here I'll introduce this 6 here, which is the value of y, equate it to 3 to the exponent of x. So that means I'm now back to those normal equation that we had previously, where you'll be given 2 to the exponent of x is equal to 3. You just introduce your ln both sides, then it's now x ln 2 is equal to ln 3, you divide by ln 2 by ln 2. That is the case that we now have here. But with the case that we have, if you are to see this part, there is no way that we can have any number that can be raised to a certain number that it gives us a 0 here. So which means actually here it's not applicable. There's nothing that we can obtain from this one. There's nothing that you're going to obtain. Even if you are to use your calculator, ln 0, you're going to see error there. That is, it's not applicable. So which means you're going to work on this. So here, let us introduce our logarithms both sides. So it's going to be ln 6 is equal to, remember that the moment you introduce ln, it will be ln 3 to the exponent of x. So you can just write this as x ln 3, because you know that you are going to drop this x. So here just write as x ln 3. You want to calculate x, yes, so divide by ln 3 both sides, by ln 3 both sides, this will cancel. So I'm now having the value of x, which is ln 3, ln 6 divided by ln 3. So that is the case. So using your calculator, make sure that you also use your calculator properly, guys. Okay, this is what you're going to obtain in this case, 1 comma, that's 1,63,092 and so on. So this one is going to be 6 3 1 to 3 significant figures, 1 2 3. It's going to be 163. It's 1,63. But if it is to 3 decimal place, this one was to 3 significant figures or 3 decimal place. Now I don't know where did I put that part. Okay, but the rounding off part of this question is another way, but this is what you have there. So as you can see, guys, these are the typical questions that you have and the stages that you're supposed to make on those typical part that you are, the stages that you're supposed to make, which are necessary. Okay, so like what I'm saying is let's say we have got something like this, guys. Maybe if I am to explain this, it can make some sense much better. We are given this using laws of logarithm, solve the equation that we have got here. So like I said, you can actually apply your logarithms direct, but this is e, this is e, these bases are the same. So you can play around that concept to say that if I am given something of the same base, okay, it's supposed to be like this, guys. E to the exponent of 3 minus x, which is equal to 2e to the exponent of minus 3x, like this. If I'm given such type of an equation, I want to solve for e. This is what I'm going for x, sorry. So this is what I'm going to do. I've got e here, I've got e here, but let's ask ourselves, guys, this is 3 minus x. So what happened here? Like the previous part, we had to subtract. When we subtract, we had to divide. So this was actually like e to the exponent of 3 over e to the exponent of x. That was the case. You were dividing the bases which are the same. That is what made you to subtract the exponents. And this is equivalent to 2e to the exponent of minus 3x. So here we're now back to that concept of a fraction. We have to clear the fraction by cross multiplying, and this is going to be e to the exponent of 3, which is equivalent, now I'm multiplying it. So it will be like this, 2 e to the exponent of minus 3x, like this. By the moment I cross multiply, it will be e to the exponent of x, like this. So as you can see, this is now a base and a base. And we know that whenever you're working with the bases which are the same and you're multiplying, you add the exponents. So it will be 2e to the exponent of minus 3x plus x, which is actually minus 2x. So this is what I'm going to have here. After cross multiplying, is going to be e to the exponent of minus 2x. Like I said, guys, from that concept. All right. So here it's easier for us to remain with the e here. So I can just divide by 2 here. So it means I can even write this as e to the exponent of minus 2x, which is equivalent to e to the exponent of 3 over 2. Just this, taking to this, just like it's one and the same. A is equal to b, b is equal to a. So one and the same thing, guys. All right. So don't freak out here. All right. At this stage that we are now, we now have a single e, like a single term. So it's easier for us to introduce the logarithm. You don't just introduce logarithms like you don't know what is happening, guys. Introduce those logarithms. When you have got a single term like this, now I can just introduce the log both sides, which is the moment I introduce the ln, it will be, remember guys, I told you the moment you introduce ln, it will be e to the exponent of minus 2x. Then you drop the exponent, so it will be minus 2x ln e, which is equivalent to ln of this part, which is e to the exponent of 3 over 2, like this. So this is what you're going to have. And we know that ln e is equivalent to 1. If you don't know this, then this is the right time for you to know this, that ln e is equivalent to 1. So if ln e is equivalent to 1, it means all this part is a 1. So you now have minus 2x times 1, which is simply minus 2x. So that is simply minus 2x, that one, which is equivalent to, because they are saying this is a 1, so it's minus 2x, which is equivalent to this part. Also, you can simplify this part at once, or you can just leave it like that and you just divide by it minus 2, or you can just simplify. I don't know what is best for you, but if you simplify, you're going to obtain something like 1,306, something like that. So make sure that you just store this value, or just leave it in your calculator like that. Then from that value, you just simply divide it by minus 2. Answer, divide by minus 2, and you're going to obtain something like minus 0.6534, something like that. So that is what you're going to have. So if you see that it's gonna, the 4 that cannot change these 3, so this will be our value of x to 3 significant figures. So guys, as you can see, it's very, very important to note the type of the question that you're working with, how to work out the question and so forth. But as you can see, these are the typical stages. So like I said, there are so many ways, but here I'm just working different methods so that we don't like focus like the first part that I did, or the first example that I did. Now you can work out so many equations. Now they can ask you a question in this format, like this one that I'm having here. Is a question which was one from one of the question papers again, where you were given that show that if y is equal to 2 to the exponent of x, then the equation, which is this equation that you see here, can be written as a quadratic equation in the form in terms of y, just like what I was doing. Then hence solve the equation, this one, you see. So they are just now giving you a conditional question where you're doing it stage by stage. But as you can see, this is what I was just doing throughout there. Okay, so let's just do it together. 2 to the exponent of x minus 2 to the exponent of minus x is equal to 1. Okay, so the first thing we are given here that if y is equal to what? If y is equal to 2 to the exponent of x. But before you do the rushing part of introducing y is equal to 2 to the exponent of x here, please do it stage by stage. Okay, here it's going to be easier if you are to ask yourself about the negative exponent from your laws of exponents. If you know that you have got x to the exponent of negative a, this was from 1 over x to the exponent of a. So for us to remove the negative here, this is same as 2 to the exponent of x minus 1 over 2 to the exponent of x. We have removed our negative from our laws of exponents, which is equivalent to 1. The moment you have introduced you have removed the negative by introduction of laws, this is now a fraction, guys. This is now a fraction. So how do you remove this fraction? Okay, you know that this is simply like, this is like over 1, this is like over 1, and this is your LCM, which is 2 to the exponent of. So to remove this, you know that you are going to multiply each term by 2 to the exponent of x, each term by 2 to the exponent of x, each term by 2 to the exponent of x to remove the fraction. So that means this will actually cancel, and this will be 2 to the exponent of x times 2 to the exponent of x, which simply means 2 to the exponent of x squared, just like 2 times 2, that is 2 squared. 3 times 3, that is 3 squared. That is the case there. All right. So this is going to give us minus 1 here because we've cancelled. So this is minus 1, and that's 1 and 2 to the exponent of x, which is 2 to the exponent of what? Of x. Now I'm just going to rearrange this equation. Just take this to the other side. 2 to the exponent of x to the exponent of 2 minus 2 to the exponent of x minus 1 is equal to 0. So this is an equation that is written in terms of positive 2 to the exponent of x, not in terms of a negative 2 to the exponent of x. So with this equation, now I can introduce the y now in place of the 2 to the exponent of x here, because you are given that y is equal to what? To 2 to the exponent of x. So in place of 2 to the exponent of x, I'm going to introduce y here. So this means it is going to be y here, but there's a square. So it's y squared minus 2 to the exponent of x, which is y like this, minus 1, which is equal to 0. So this is the equation that I'm going to formulate or to have at the end. All right, so are you seeing how they ask this? So this is the question that they said, show that if y is equal, then this can be written as a quadratic equation in terms of y, which means we are talking of an equation that is only y like this. Then hence solve. If you are given hence, there's no way, you have to follow from where you are, but they can write this hence or otherwise. If you are given otherwise, that means you can actually use another concept, but here you're supposed to continue from this. So how am I supposed to continue from this? Definitely I have to solve just like the previous part, but this time I'm having a quadratic equation. So I'm going to solve my quadratic equation. Y squared minus 1 minus y minus 1 is equivalent to 0. So solve this equation. I don't know if factorization is clear, but by looking of things, the factorization is not going to be fine because we do not have factors of minus 1 which gives us minus 1. They do not exist. So use your quadratic formula. Y is equivalent to, you know your formula, guys. That's going to be x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So in this case, it's y is equivalent to minus b, which is actually minus 1. So it's minus 1 plus or minus the square root of b squared. That's minus 1 squared minus 4ac That's 1 here, and our c is -1. Everything over 2a, which is 2 times 1. Okay, from your O-level mathematics, guys, you can actually revise this under this platform. I talked about all these topics, so you can actually revise this, your O-level stuff, if maybe you've forgotten. All right, solving properly, you're going to obtain two possible values. In this case, I obtained 1,61803, something like that. So make sure that you store your values. All right, or another value of y, which is equivalent to -0,618, and so forth. You store your values. Okay, so these are the values of y, not the values of x. So how am I going to find the values of x? I'm going now back to that introduction that we did, because remember, we introduced y to represent 2 to the exponent of x. So if we introduced y to represent 2 to the exponent of x, therefore I'm going to equate the first value of y, this one, 1,61803, and so on, is equal to 2 to the exponent of x. Then on the other side, I've got another value of y, which is here, -0,618, which is equivalent to 2 to the exponent of x. Therefore, I have to solve for x. Now I'm able to solve for x, but if you are to cross-check here, okay, I'll talk about this. Let's just introduce our log, which is ln 1,61803 is equivalent to x ln 2. Remember this, guys, and I think now you are now used to this. Drop your exponent, ln 2. So to find x, then you have to divide by what? By ln 2. Don't panic, guys, don't panic. This is maths. Okay, just divide by your ln 2 both sides. You have got the value of x in this case, which is going to give you, just simplify properly, you have got 0,69424, something like that. So to 3SF, I'm just going to leave to this part. On this part, the moment you introduce your ln, you know that this is a negative, and we do not have a condition of a ln of a negative number. This does not exist. Or the log of a negative number. This does not exist in maths. So definitely here, it's not applicable. There's nothing. It's not exact. There's nothing that you're going to obtain from there. But here, your x is going to be this. So therefore, this is the only value of x that you're going to have. So guys, do you see how they ask these questions? These are the typical questions. So I want you guys, with the idea of what we have been talking about, to now try this question where you are given from one of the question papers that are given that x is equivalent to 4 into 3 to the exponent of -y. Express y in terms of x, and that is actually 3 marks. So I want you to apply your skills that we have been talking of from this class to try this question. And don't forget, guys, to give your feedback. So that's it, guys, from Mason African Motives. Till we meet again. So don't forget also, guys, to share our platforms to your friends and to your colleagues at schools that you are there, so that they also can benefit, or they also can learn from this platform that we have to change lives actually from this channel. So please, guys, do this as a favor to the channel, and also as a favor to our family as a Mason African Motive family. So that's it, guys, till we meet again.